So this video will go with forces, but also with collisions. I wanted to talk a little bit about concussions, since most of you are in the health professions area. And if you're a sports fan, you know that concussions are a big deal. Um, for those of you that are not familiar with concussions, American football is the number one sport for concussions, and then women's soccer is number two. Um, when this is not a sexist comment, even the female soccer players will say the same thing. Their necks are designed differently than men, and their necks are a little bit weaker. So when they go up for headers and they hit each other on the side, they get whiplash and they have a concussion. So women's soccer is number two, and American football number one. Rugby, as crazy as it is pretty low on the list. So you can take that for what it's worth. But so let me kind of draw a skull here. So again, your face, your eyes, and so forth. But your brain, for those of you who are not familiar with the biology, your brain sets in here loose inside your brain. And so you think about if you're moving forward, if you're moving forward as a whole, everything's moving. And if for some reason, all of a sudden your brain, and I know I can't draw a brain, I'm biology majors, art majors, I'm sorry, all of a sudden comes to a stop. So you have a quick stop. The brain actually will get smushed up against the front, and depending on how hard it hits, you can get bruising here. And that's the concussion. And I'm going to post a video, Johnny Damon's baseball video. It's a really interesting aspect of how they studied the science of his collision. And you'll see actually when the head rotates, that's where greater symptoms occur and greater impacts occur. But this is all because of Newton's first law. An object in motion remains in motion until a force acts upon it. The skull all of a sudden comes to a stop. The brain, which is not attached, keeps moving, moves forward. That's how you get whiplash. So let's say that you're sitting at a red light, you're here, and your brain's here, and you're stopped, and someone comes in and hits the car from behind. Well, your body moves forward because the back of the seat is pushing forward, but your head stays where it was. So if I try to draw it here and try to draw in the same picture, if I'm looking at the side, your brain stays here, but your neck is being moved forward. That's the whipping part. And then eventually the muscles in your neck, the tendons in the neck, whip your brain and the head forward. And what happens is you get whipped, and then all of a sudden it has to come to a stop, lash. And it's still Newton's first law, an object at rest remains at rest until force acts upon it. So these concussions are due to Newton's first law, and then conservation of momentum, which is going to be chapter 8. So when you're looking at this, how do you prevent, how do you minimize the damage to the brain? Ultimately, the only way you can prevent a concussion is to never move your brain, never move your skull. But that's impossible unless you're just going to never move your body. So how do you minimize how much motion this occurs and absorbing the force impact? So one of my research projects I did, if you've ever seen soccer players, they wear some of them wear headbands, and it's supposed to absorb the impact. One of the research projects I have been working on was, do these headbands actually do as they claim? Like, for one, it advertises that it reduces the force impact by 50%, but they have no data. So they're very unscientific, and they have no data to share. They never share any of their reports. So if you're interested in a research project, that's one of the projects I've kind of been working on, is, do these advertised object materials actually do as they say? So it's an interesting aspect. All concussions, all because of Newton's first law. And how do we prevent it? For those of you who are not familiar with why this is such an issue, CTE, there are several football players that have gotten dementia, committed suicide, and these are all sign impacts of brain damage from these concussions. And so they're actually a really big deal. And it's not just football players and soccer players. I know I've seen volleyball players. I've had several students in class that have had concussions, whether from driving, sports, or whatever, and they play a major role. So this is a big area in the medical field for people to work on.